Okay, here is a projectile motion question. We have a motorcycle stunt rider, and he rides off the edge of a 10.0 meter cliff. Just at the edge, his velocity is horizontal, with a magnitude of 9.0 meters per second. We want to find the motorcycle's position, distance from the edge of the cliff, and velocity after 0.5 seconds. How long does it take to reach the bottom of the cliff? So the first thing we want to do is always to draw a picture. So here is my picture. And I have a motorcycle stunt rider. Okay, there's a motorcycle. And he has some horizontal velocity. So as soon as he goes off the ledge, we know he will start to fall. And we know the path will be parabolic in nature. So some other things we know, say here's the ground. We know the height here is 10 meters. We know the velocity, the initial velocity is 9.0 meters per second. And for one of the questions, it says, what is the velocity after 0.5 seconds? So maybe it's around here. One thing to note is that the velocity vector is always tangent to the path of our trajectory. So if I draw a line that just passes a single point on this line, this will represent our velocity vector. And we can separate this into x and y components as well. This would be vx and some vy at that some point 0.5 seconds. Okay? With some angle theta, of course. So one key thing to remember for kinematics in grade 12, again, because we are ignoring air resistance, there is only acceleration in the y direction. So this is our key equation. D is equal to v0t plus 1/2 at squared. Now one thing to note is that in the x direction, because acceleration is 0, this 1/2 at squared term pretty much goes away. Right? So d is equal to v0t. That's what we're left with in the x direction. In the y direction, because of acceleration, we use the whole thing. So when starting out with these problems, sometimes it's a good idea to list what you know somewhere off to the side. As you get better at these, you can just go straight ahead and solve them. So in the x direction, let's list what we know, and in the y direction, let's list what we know. So you know that Vx is equal to 9.0 meters per second. Dx, that's how far we will travel as we fall. And that is an unknown right now. And our time, or at least for one of the questions, is going to be 0.50 seconds. So we'll solve for that one. In the y direction, we have, I'm actually going to separate into the v0y and v final y, because we know that in the y direction there is acceleration. That means our velocity is going to be changing. So when we look at this one, because our initial velocity is in the horizontal direction, initially we have 0 meters per second in the y direction. We do not know what the final velocity is, but we know it's going to speed up at a rate of 9.8 meters per second squared. That's our acceleration. 9.81 meters per second squared. D is 10 meters. And, well, it's 10.0, so 36 bigs. And we have T is equal to 0.50 meters. Now, before we start, we have to make sure we have our sign notation. So usually, because when I look at this one, I can say, I'm just going to choose down as the positive direction. So that way I can say, okay, if down is positive, acceleration is down, that's going to be positive. Displacement, D, we're going from somewhere high to somewhere low, we're going down, so that's also a positive value. If you defined up as positive, then we have to recognize that this will actually, acceleration will be negative, displacement will be negative. But by choosing a down as positive, it makes our life a little bit easier. So here's our first question. It says, find the motorcycle's position, distance from the edge of the cliff, and velocity after 0.50 seconds. So in the x direction, Pretty straightforward. So let's look at position first. So position after 0.50 seconds. So let's find the x, the horizontal first. Horizontal. So in the horizontal direction, we know we can just use this equation: d is equal to v0t plus 1/2 at squared. There's no acceleration, so you just get dx is equal to vxt. So dx is equal to 9.0 meters per second multiplied by our time, which is 0.50 seconds. So you get dx is equal to 4.5 meters. Right. In the vertical direction, we have to use the equation dy is equal to v0yt plus 1/2 at squared. So in this case, we know that our initial velocity in the y direction is 0, so that's just going to go away. So we end up with dy is equal to 1/2 multiplied by our acceleration, 9.81 meters per second squared, multiplied by our time, which is 0.50 meters, and we end up with a y value of 1.2 meters. So after 0.05 seconds, we've only actually fallen 1.2 of those 10 meters. Okay, sorry if I have to write that square right there. So that's part one. So next is, what is our velocity after 0.05 seconds? I'm just going to write that over here off to the left. So velocity after 0.50 seconds. It's going to separate into x and y again. So if I look at horizontal, and key idea, velocity in the x direction does not change because there is no acceleration in the x direction. So I know Vx is still 9.0 meters per second. In the vertical direction though, we do know it is speeding up. It's getting faster. There's some other equations. If you looked above in the notes, we have Vy is equal to V0y plus at. So we know our velocity is going to going to increase at a rate of 9.81 meters per second squared. So you just have Vy is equal to 0, so that's 0 because we started with 0 meters per second. Our acceleration is 9.81 meters per second squared. And our time elapsed is 0.50 seconds. So you get Vy is equal to 4.9 meters per second. So to be careful here, because we are actually not quite done this question, because velocity is a vector. So we actually need to combine Vx and Vy together, just like we would in our previous topics. So at this point, we can see that Vx, the x component of velocity, is 9.0 meters per second. The y component of our velocity is only 4.9 meters per second. But what we can see is that our velocity is the hypotenuse of that triangle that is formed. So we go 9 squared plus 4.9 squared, and we can square root that value. We end up with a value of, so V velocity at 0.5 seconds comes out to be, so that's 9 squared plus 4.9 squared, square root 10.2, rise around to 10 meters per second. So we have 10 meters per second, and we also need an angle as well. So we go inverse tan of 4.9 over 9, we get a value of 29 degrees below the horizontal. So I can't actually use northeast, southwest in this case because we're traveling up and down. Right. So 10 meters per second, 29 degrees below the horizontal. And last part of this question, how long does it take to reach the bottom of the cliff? So time to reach bottom. So can just use this equation. We have dy is equal to v0yt plus 1/2 at squared. So we can plug in, well, first of all, we can note again that this term goes to 0 because our initial velocity in the y direction is 0. So how far do we travel? We travel 10.0 meters. Right? 10.0 meters. We know our acceleration is 9.81 meters per second squared. And we can solve for t squared. So 10 times 2 divided by 9.81 square root. You get a value of 1.43 seconds. And that is our final answer.